Okay, let's get into some more mathematical terms, mathematical definitions and symbols. It says a set is well defined here, something you need to know, if it is possible to determine whether any given item or is an element of the set. For instance, the set of letters of the English alphabet is well defined. It's clear what's in there and it's clear what's not. The set of great songs is not well defined. Why is it not well defined? Because it's not possible to determine whether any given song is an element of the set, or is it not an element of the set because there's no standard method for making such a judgment. In other words, well-defined means it's clear you are in the set. Let me write this over here. Well-defined means it is clear what is in the set. Okay, not well-defined is often opinion-based. So what do I mean by that? Think about the set of songs, good songs. Isn't that an opinion? Isn't it an opinion to you and to me which song is a good song and which song is not a good song? The set of best movies, the set of best presidents of the United States, anything that is open to interpretation. If it is open to interpretation, it is not well defined. If it is extremely clear, natural numbers less than 4, that is called a well-defined set. It is clear what is in there or not. Okay? So, says the statement 4 is an element of the set of natural numbers can be written using mathematical notation. So let's look at this mathematical notation right here. That 4, if you see that little E symbol, that means that E symbol is element of. Likewise, we can easily say something's not an element of. Not an element of, you're going to use this symbol, an E with a slash through it, okay? So look at this one right here. It says -3 is not an element of the natural numbers. And that's true, because the natural numbers are the numbers 1, 2, 3 on up. So -3 is not a natural number. And 4 is a natural number, as it says in the other one. So when you use this mathematical notation, what does it do? It takes an English sentence of many words, and you can do it in 3 symbols. Mathematicians are very lazy and like condensing writing as much as possible, so we use this notation. Do you have to use this notation? No. When you write an answer, I am perfectly fine with you writing the long English sentence instead of the math notation. However, if you do use the math notation, I will still accept your answer. So why are we covering it? Whether you use it or not is up to you, but what's not an option is you need to know how to read it. So you need to understand, like in the next problem, if I use math notation or the textbook or question uses math notation, you at least need to be able to read it and understand what is it saying. So, when I do true-false statements, I want you to picture me in front of you reading a statement. If I just told the truth, you circle true. And if what I just said was false, then you circle false, okay? Did I just say something that's true or not? So let's look at this first one. The way that I'd read this is 4 is an element of the set 2, 3, 4, 7. So 4 is an element of the set 2, 3, 4, 7. Did I just tell you the truth or not? And the answer, hopefully you think immediately, is true. Why is it true? Because 4 is in the set. Okay? How about the next one? I'm going to read this sentence to you. You tell me if I'm lying or not. -5 is an element of the natural numbers. -5 is a natural number. Is that a true statement or not? Well, that's a false statement. Why is that a false statement? It's a false statement because -5 is not a natural number. Let's look at this next one. 1/2 is not an element of the integers. 1/2 is not an element of the integers. Remind yourself what the integers are. It's positive and negative numbers here. So 1/2 is not an element of the integers. That's true. Why is that true? Because 1/2 is not an integer. I didn't lie. I told the truth. Okay. The set of nice cars is well defined. Again, well defined, let's think about this. Well defined means it's clear. No matter who reads the problem, everyone agrees what's in the set. Would everyone agree on what nice cars are? And the answer is no, so that means it is not well defined, so that would be false. Why is it false? Why is it false? It's false because it's open to opinion. Okay? If it's open to opinion or open to interpretation, then it is not a well-defined set. Okay, let's move on. Now, one thing I do want to notice, in this class, no answer goes without work. You have to justify it. There's very few answers. Like if I said, what are the days of the week? There's nothing to show there. You either know the answer or you don't. But on any true and false problem, you have to justify your answer. So just circling true or false, just answering true or false is not enough. You need to tell me why. Okay? Let's look at this next one. Determine whether each statement is true or false. My statement is 5.2 is an element of the set 1, 2, 3, 4, 5, 6. Let me say that again. 5.2 is an element of the set containing 1, 2, 3, 4, 5, 6. Did I just tell the truth or did I lie? Well, the answer is I lied. That is false. Why is that false? Because 5.2 is not in the set. That would be my justification. That's what I would need to write down on my paper for the test. That's what I'd need to write on the extra practice problems. How about this one? B, negative 101 is an element of the integers. So ask yourself, is negative 101 an integer? Well, remember, integers are both positive and negative numbers. Integers are both positive and negative numbers. So that is true. Why is it true? Negative 101 is an integer. That's all you have to tell me. How about the next one? 2.5 is not a whole number. 2.5 is not an element of the whole numbers. Remember, whole numbers are 0, 1, 2, 3, on up. So 2.5 is not a whole number. Think about that statement. Is it true or false? The answer is, it is true. Why? 2.5 is not a whole number. Okay. The set of all integers larger than pi is a well-defined set. So what's the number pi? Pi is 3.14. Could you think of integers? Remember, integers are positive and negative whole numbers. Can you think of the set of integers greater than pi? Well, wouldn't that be the numbers 4 on? 4, 5, 6, 7, 8, and on, right? And it's clear what's in there. It starts at 4 and it goes all the way up. It doesn't include anyone else. So is that well defined? The answer is true. Why is it true? Because it's not open to interpretation. There's a definite answer there. It's very clear. Okay. So those are the true-false questions. While you guys maybe think those true-false questions are easy, I will tell you a surprising majority of students miss several true-false statements on the test because you forget to step back and read it. And you think about, like, for instance, let's look at this one right here for C. This is a problem that a lot of students would have actually circled false because what they're thinking about is 2.5 being a whole number, and they're saying 2.5 is not a whole number, so they would circle false. Well, but the statement is true because the statement does say 2.5 is not a whole number. So you've got to be really careful. You are stating whether the statement is true or false. So step back. Imagine me reading you the statement, then circle true if I told you the truth, circle false if I told you a lie. Okay, let's look at the next one. The next one is about the empty set, or the null set is what it's called. You can draw it two different ways. You can either draw the circle with a slash through it, or you could put the braces there. One or the other, but not both. Pick one and stick with it. The one with the braces with nothing in it, that's the roster method version of it. The Greek symbol for the empty set or null set, mathematical symbol, is the circle with a slash through it. I want to show you guys something that drives me absolutely nuts. I have a lot of students who do stuff like this. Their teachers taught them at a young age to do something like this. Imagine this equation, x plus 2 equals negative 2. I did that wrong. X plus 2 equals, let's do a positive 2. So if I said solve this, hopefully you would subtract 2 from both sides, and there's students here that would write this, x equals the empty set. And people write their zeros like this. This is not a 0. A circle with a slash through it is not the number 0. A circle with a slash through it is the empty set. There is a solution to this equation. The answer to this equation is 0. X equals 0 is what it should be. And if we wrote it in roster method, it would be the set containing the number 0. When you write this here, this 0 with what you think is a 0, a circle slash with it, you're essentially saying there's no answer, right? You're saying here's the set and it's got nothing in it. So be really, really careful. You either use you either use the empty set or you use braces with nothing. That's what the empty set is. Never, ever, ever use a combination of them. And never, ever, ever use a circle with a slash through it to indicate the number 0. If that's how you write your zeros, change it now. Trust me. Okay? So, it says, note, neither the set containing 0 or the set containing the empty set represents the empty set because each set has one element. Write one or the other, but not a combination of the two. So I'm going to highlight that. Write one or the other, or not a combination of the two. All right, so what's the next thing you need to learn? You need to learn set builder notation. So it says set builder notation is especially useful when describing infinite sets. For instance, in set builder notation, the set of natural numbers greater than 7 is written as, well, let's think about this. So what are the set of natural numbers greater than 7? Well, if we had to write the answer in roster method, the numbers greater than 7 would be what? Wouldn't it be 8, 9, 10, and then it would go on forever? So with infinite sets with roster notation, you must use ellipses, and you must use ellipses appropriately, meaning you have to have at least 3 things written before them, right? But the question is how can I write this in a different method? And that's the next method, which is called set builder notation, which we'll do on the next page.